Section 2.2, we're looking at comparing regular equations to root equations. So in this case, if we have our regular equation, what would it look like if we had the root of that equation? So if we look at the graph, this is a linear equation. We know that the y-intercept is 3 and that this is the slope, so it's going to fall to so it goes down 1, 2 and over 1, and then that forms our line. Okay, and what happens when we have the root of that equation? All that means is our x and y points, our x points stay the same and our y's become the root of whatever our y points were. And you'll notice these 2 points show up on both graphs. So those are the invariant points. It's 1 and 1 and 1.5 and 0. Okay, so whenever y is equal to 0 or 1, those are going to be your invariant points of root equations. So looking at example 2, it says identify and compare the domains of the functions in each pair. Okay, so if we have these equations, these are supposed to have roots over the top of them, and this one. Okay, so if we look at those and we want to see the graphs that correspond with them, this is your normal parabola, and when we put the root over it, it looks like this. Okay, so the domain for the first equation would be all real numbers, because it goes on and on. So x is all real numbers, and y has to be less than 2, because it goes from here down, less than or equal to 2. Okay, and when you look at the domain and range for the second function, the domain is between x has to be greater than -2, but less than 2. And for the range, y has to be greater than 0, but less than, I think that's 1.5. Okay, so if we look at our next picture, this is the normal parabola. All it did was it had a transformation of 5 up. And when we do the root of that equation, we get that picture. Okay, so if it says compare the domains and range, it's very similar. So the third example says use the graphs of y equals f of x and y equals g of x and the graphs of their roots. So we would have to sketch the graphs of the roots. So remember we said the invariant points occur when y equals 0. So when y equals 0 is right here. And we said when y equals 1, which is right here. So those are our invariant points. They're going to show up on both the graphs. And we know that our graph is hitting on 4 originally, so it's going to be the root of 4, which is 2. It'll hit on our next one. So if I can connect these, this is what the graph of that equation is going to look like. Okay, and again, when y is 0 and when y is 1, so when y is 0 and when y is 1, and so the graph of that equation is going to look like that and like that, sort of more round.